Welcome to the Planet of Maths channel. In this video, we'll learn how to draw a linear function graph. That is, a function given by the formula y equals ax plus b, or alternatively, f of x equals ax plus b. Both of these notations represent the same function, a linear function. In the first task, we have to draw the graph of the function f of x equals 2x minus 1. This is a function in which coefficient a equals 2 and coefficient b equals negative 1. To plot the graph of any function, you make a table. I make such a table to start with. If we are just learning to draw the graph of a linear function, then put 5 of these free columns in the table for starters. Then, once you get the hang of it, you can make fewer columns, but I advise starting with this many. In the top column, where the x's are, we essentially choose any numbers. Most often, numbers from -2 to 2 are chosen. It's important to enter these numbers sequentially. Then we have to calculate the bottom row ourselves. In the lower section, we will be entering f of x or y, and we will be calculating it. Because we can enter x essentially randomly, you can also enter some other values. But down here, it needs to be calculated. We calculate it from this formula. We take this formula, and first, our x becomes the number -2. So here in place of this x, we'll go at the start -2, and it will look like this. We calculate f of -2, meaning we substitute -2 for this x, remembering that there is a multiplication between the 2 and x. So here, when we replace x with -2, we get 2 multiplied by a negative number. We have to remember that this negative number must be in parentheses, and that was the x replaced by the number -2, and then -1 written down again. We multiply these two numbers. 2 times -2 equals -4, and then there's the -1. Finally, it comes out to be -5, and we enter that into the table. Now our x becomes the number -1, so we calculate f of -1. And again, it is 2. Just like in the formula, we multiply 2 by this negative number in brackets, and -1 is copied from here. This times this equals -2, subtract 1. This gives us a result of -3, and we enter it here in this column. The next x is 0. So we calculate f of 0, we take 2, multiplied by x, which means by 0, and subtract 1. 2 times 0 is 0, and subtracting 1 from 0 is -1. And that's our next number at the bottom of the table. The next x will be 1. So we calculate f of 1, write 2 times x, which means 2 times 1, and subtract 1 from it. 2 times 1 is 2, and 2 minus 1 equals 1. So here we have 1. And our last x is 2. So we calculate f of 2. f of 2 is 2 times x, which is 2 times 2, and subtract 1. 2 times 2 equals 4. Subtract 1, that makes 3. Well, we have the table filled out. This table gives us points. Each vertical column of the table represents a point. From this part of the table, we have such a point. The first coordinate is this x, the one from above, which is -2, and the second coordinate is -5. We can mark this point straight away, -2 and -5. And -5 we're going down. This point won't exactly fit here, but that won't be a problem. The next point is -1 and -3. Point -1 minus 3 is marked like this. We start from here. -1 means to the left, and -3 means down. This is our first point. The next one will be from this category, and here at the first spot we have 0, and at the second spot we have -1. Such a point is marked in this way. The first coordinate 0 means that from this spot we neither move left nor right. The second coordinate being -1 means we go down by 1. That's it. The next point is the coordinates 1 and 1. 1 to the right, 1 up. And the last point is the point with coordinates 2 and 3, meaning 2 to the right and 3 up. 2 to the right, 3 up. So, as we can see, these points nicely align in a straight line. We can then draw the graph of this function. This is a line, we can label it f of x equals 2x minus 1. And here I want to point out that the graph of every linear function will always pass through point 0b. In our case, b equals -1. So this point is 0, -1. 0, -1 is this point. And it's special because it's the point where the graph intersects the y-axis. So pay attention to that point. 0, -1, so 0b. In the second task, we need to draw a graph of the function f of x equals negative x plus 3. Let's set our coefficients. The coefficient a, which we can't fully see here, is negative 1. There's an invisible 1 before this x, and the b coefficient is the constant term, which is 3. We need such a table, and we put the same numbers into the table as last time. We take the formula of our function, which is f of x equals negative x plus 3. Firstly, x for us is the number negative 2, so we calculate f of negative 2. Thus, this will look like this. Here, instead of x, we will use this number, and if it's a negative number, then it must be put in parentheses, so the minus comes first. Then in parentheses, we have the number negative 2 and plus 3. These two minuses give us a number positive 2. Plus 3 equals 5. We have a 5 here. The next x is negative 1. So we calculate f of negative 2. We put a minus. In parentheses, we put an x. So negative 1, and then we add 3. Out of two minuses, we get plus 1. Plus 3 makes 4 altogether. The next x is 0. So we calculate f of 0, and there is minus. Here instead of x, it should be 0. So I don't need to put it in parentheses because it's not a negative number. And add 3 more. Negative 0 is simply 0, thus we get 3. Here we have 3. Now x is 1, we calculate f of 1. So this will be a minus. There will be x, which is 1, and it will be plus 3. From this we get 2. And the last x is 2. So f of 2 is a minus. Instead of x goes 2, and plus 3. Here we get the number 1. The table is ready, so now we take the points. The first point from this category will be the point minus 2, 5. Minus 2.5 means from this point. From the origin, we move 2 to the left, then up 5. This is the first point. The second point is the point with coordinates negative 1 and 4. Negative 1 says go left, and 4 says go up. 1 to the left, 4 up. The next item is item 0, 3. 0 says neither to the right nor to the left. 3 says 3 up. 0, neither right nor left, 3 up. The next item is item 1, 2. This point will be 1 to the right and 2 up, 1 to the right, 2 up. And the last point is point 2, 1, which means 2 to the right, 1 up. 2 to the right, 1 up, that's here, and the points have nicely lined up in a straight line again. Let's draw this line and label it. And I'm pointing out again the point 0b that every linear function's graph goes through. In our case, this 0b point is the point 0,3. This is the point, and this is where the graph intersects with the y-axis. In the third task, we have to draw the graph of the function f of x equals 2, which is a rather unusual looking function. We must read the formula of this function in this way. It is the same as f of x equals 0 times x plus 2. Because something like 0 times x cancels out, it will still be 0, so only 2 remains. Here we need to be aware that our a equals 0 and b equals 2. This is such a function. We take our numbers to this table. First, we take x negative 2 and calculate, according to our formula, f of negative 2 is 2. Here we have nothing to count on. The result has to be 2, because there is no x to substitute for. Here there is 2. The next x is minus 1. No need to count f from minus 1 again. It will also result in 2. With these next x's, it will be exactly the same. Nothing different ever comes out. It always has to be a 2 here. It's a special function. Let's see what points we have from this. The first point is point negative 2, 2. And this point, negative 2, 2, it is minus 2 to the left, 2 up. The next point will be point negative 1, 2, meaning 1 to the left, 2 up, 1 to the left, 2 up. 0, 2 is another point. That is, 0 to the right to the left, 2 up. It will be right here. The next point is 1 minus 2, meaning 1 to the right, 2 up. And the last point is right here. We draw a straight line and label it. This is the graph of a constant function. A constant function's graph, meaning one that is parallel to the x-axis. This is a special function, but it still passes through the point 0b. 0b means 0, 2. 0, 2 is here, and this is our special point. That is the point where the function's graph intersects the y-axis. And that's all for this episode. Thank you for watching, and I invite you to tune in for the next episodes on the Planet of Maths channel.